This is the first lecture for Chapter 9 from McGraw-Hill, Chemical Reactions. So start out by talking about what a chemical reaction is. This is the way that chemists put on paper or communicate how reactions take place. Reactants are put on the left, there's an arrow, and then there's products on the right to show you what actually happens in the real world. We need to be able to recognize when a chemical reaction occurs. Here are some of the evidences: release of heat or light, if you touch it and it's hot, or if you touch it and it's cold. Those are both evidences of chemical reactions. When it's cold, it's endothermic. Remember that? It's important in this chapter and really all year. N means heat goes in. X means heat goes out. Exothermic means that it feels hot. Endothermic means it feels cold. Release of bubbles or gas, odor, color change, formation of a solid. Any of those could be evidences of chemical reaction. If you have one of them, could be. If you have two or three of them, chances are real good you have a reaction. All right, well, that'll move on when it moves on. Like we said, reactants are on the left and products are on the right. One of the questions I'll be asking you on the quiz and the test will be, I'll give you a reaction and I'll say circle the reactants, put a box around the products, and tell me what the arrow means. So reactants are on the left, products on the right. The arrow means produces or yields. We can have several different types of ways to communicate equations. One of them could be word equations. So it might say aqueous hydrochloric acid plus solid magnesium produces gaseous hydrogen and aqueous magnesium chloride. That would be a word equation. We're telling you the states of matter. We're telling you, what kind of possibly solution it is, and the reactants and products we're mentioning by name. So it's important that you know how to translate that. We've done that in the last two chapters, learning how to translate from names to formulas and formulas to names. Important to be able to do that. Skeleton equation is an equation that is in formulas, correct formulas, and reactants on the left, products on the right, arrow in the middle, and it's not balanced. Then, of course, all equations that you deal with should be balanced. So the first thing you should look at is it balanced? Count the atoms on the left of each type, atoms on the right of each type. If those are all equal, then you're good to go. Law of conservation of mass says that when we do a reaction, we don't destroy matter, but matter and mass is conserved. So that means if we start out with 50 grams on the left, we're going to have 50 grams of product. Now, some of the demos we've done this week, you've seen that fumes go up and vapors go up. Yes, we may lose some of it to the atmosphere. It goes out the fume hood, but we haven't destroyed it. It's just gone somewhere else. So if you had a closed system and you weighed it before and after, then the amounts would be equal. Law of conservation of mass. The way you're going to find out that we balance equations is by using coefficients. That would be a whole number that we put in front of substances to tell you how many. It's kind of like 2 eggs and 3 cups of flour mixed with 1 tablespoon of oil and 1 cup of milk. Okay, all those numbers are just like the coefficients that we use in chemical equations. And at the end, they should be whole numbers, and they should also be most reduced. So if you had numbers of 2, 2, and 2, you'd want to reduce all those to 1, 1, and 1. On page 286, they give you the steps for balancing. Here they are on the notes. First thing is to have a correct skeleton equation. So if you don't have a skeleton equation, if you've got a word equation, write it in skeleton form. Make sure that it's correct. Some things to remember. Don't forget about the diatomic gases, the 7 that start at 7 on the chart, and the shape of a 7. Easy to remember. So you start with nitrogen, which is number 7, and nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Look at your chart and you'll see that that's in the shape of a 7. Remember, hydrogen's the 7th one and it's always in the wrong place at the wrong time. So next, you're going to count the atoms on both sides, and you're going to try to usually start with the biggest substance and try to put a number in front that helps to balance one of the types of atoms on both sides. But if there's more than one thing, like if there's Na and Cl and you put a 2 in front of the NaCl, yes, that gives you 2 Cl's, but it also gives you 2 Nas. You've got to go back and look at the other side. And you keep going back and forth to put numbers in front that will balance at the end, balance all of the atoms. Once you're done with that, check that you've got correct numbers, it's balanced, and it's most reduced. You always should leave it in most reduced form. So here's a couple of practices. You could pause and try to balance these. The first one is very easy. Second one is easy. On 0 to 5 difficulty scale, this is probably 0 and 1 of difficulty. So go ahead and pause and try to balance those and see what you get. And we'll check that out in a second if you want to go ahead and take that time right now. So when you get finished with this, you should have a 2 on the first one in front of the HCl, and then it's balanced. It's that easy. The H2 and the Cl2, remember, those are both diatomic. That's why the little sub 2 is there. You can't keep the sub number when you go across the arrow. You always drop those sub numbers and refigure them on the right, because the situation on the left is they're by themselves and they need to be H2 and Cl2. When they join together, there's no sub number 2s anymore, because H and Cl are now buddies. They don't have to have another H and another Cl to be buddies. But you put a 2 in front, and that gives us 2 H's and 2 Cl's. We're balanced. On the next one, you notice that we've got Br2 and AlBr3. Whenever you've got 2 and 3, you're going to have to make sure you do 3 times 2 and 2 times 3. Target trying to get 6 bromines. And once you do that, you'll have to go back and put a 2 in front of the Al. So your final balance should be 2 Als, aluminums, plus 3 Br2s, yield 2 AlBr3. That would be the balanced form. So we're going to talk about types of chemical reactions, and this is just a quick survey of types. The next set of notes, the next video, you're going to be able to see each type. We're going to spend some time with those. I do have some practice pages. They give you a little section of combination reactions, also called synthesis or composition, decomposition. So there'll be like 4 or 5 of each type, and you've got to complete them, balance them, and for some of them, they're word equations, so you have to be able to write the formulas. Go through and do as many of those practices as you can. Some of the questions on the quiz and the test will come from those practice pages. Most of them will also be on your review. So, synthesis reaction. 3 names for this you need to be familiar with. Synthesis, composition, and combination. Those are all used out there for these types of reactions. So, make sure that you know that they're all equal. They're always one of those 3 names. We're going to bump to the second type, which is decomposition, and decomposition is just the opposite. Now, as you go through, part of what you're going to do in this chapter is you're going to need to be able to write over on the left side. I'm going to have a blank for each reaction that says what type is it. And there's also a practice that's just strictly that. Recognize the types. You fold it over, say, I think that's synthesis, and then flip it over and check yourself. If you miss some of those, then you need to come in and get help. That indicates specifically, 1, that you've put in some time and you've learned, and 2, that you know what you need to come get help with. For the synthesis, the first type, you look at them and they have 1 product. The synthesis you all see will have 1 product. 2 things come together, you end up with 1 product. So if it has 1 product, synthesis, or combination, or composition. Decomposition has 1 reactant. Now, there are some more complicated ones that are combinations of things, but for y'all, it will be a one reactant, and it breaks into 2 or 3 products. So, one reactant, decomposition. Combustion is the second one on this list, and combustion to me is the easiest kind because it always follows the same template. So we have some carbon fuel, and we'll talk about some special cases like where we burn hydrogen instead of carbon. But for y'all, I'm going to try to give you the carbon combustion, so it'll be some carbon compound, and we have O2 always as a reactant, and the 2 products are always CO2 and H2O. So what you should do is try to remember this the way that I teach you to remember, and the way to remember is for all combustion, you need to do this. Go. Okay, you breathe in, that's O2. You breathe out, and like if we breathe on a piece of glass, you can see that there's moisture. So we breathe out water and we breathe out CO2. So in with the oxygen, out with the CO2 and water. And if you can remember it that way, you won't forget any of the parts. About 1/3 of the people that miss this forget to add oxygen. The way I will state the question on the test is I will say, show complete combustion of, and then I'll give you a compound, a carbon compound, like CH4. So you need to know, okay, complete combustion, add O2, arrow, CO2, and H2O for the products. If you do that, you can't help but remember it. But some people think that's a little too corny, so they miss the O2. The other type of combustion, there are 2 types. The other type, this is complete, is if you erase the 2 on CO2, we now have CO, which is carbon monoxide, and that's incomplete combustion, where you have carbon monoxide and water for products. Other than that, same template. That's why these can be fairly easy, because it's always the same thing. You just have a different fuel each time. Now, 2 special examples on this, and we'll talk about this more tomorrow on the next video when we talk about combustion types in a little more depth. But if you have hydrogen only, and you do combustion of hydrogen, kind of like the balloon we did, where we had a hydrogen balloon, we hydrogen oxygen, we lit it, boom, okay, that's combustion of hydrogen. There's no CO or CO2 because there is no C in our fuel. Since we just have hydrogen, hydrogen plus O2 yields H2O, and that's why hydrogen is such a valuable fuel and will be in y'all's lifetime, that we will learn lessons and figure out that we need to be a little kinder to the environment. We'll start burning hydrogen. That would be great for y'all down at our coastline, and even up, up in this area. You could truck up the salt water. It just costs a little extra. But down at the coastline, we will have factories where they will take salt water and they will put plus and minus electrodes in it and produce hydrogen and oxygen. It's one of the demos that I did in this chapter for electrolysis. So you could do this. I just took the 9-volt battery to 2 cables, we put it in, hydrogen and oxygen bubble up on the 2 wires. So at any rate, make sure that you know how to do complete, incomplete, and then also that you know what hydrogen combustion is. So we'll move on, and we already talked about decomposition, single and double replacement. So, so far, how do we recognize these? Synthesis has 1 product. Decomposition, 1 reactant. Combustion always has O2 on the left side. And if you don't have the right side evident, then, just look for the O2 and you'll be able to recognize, oh, that's got to be some type of combustion because it's got oxygen. In almost every case, that's going to help you, and that'll be true. If you have the whole thing and you see the CO2 and the H2O, then it's dead giveaway. And remember, for incomplete, it's CO instead of CO2 for the product. So single replacement, how are we going to recognize this? Well, Single replacement has one element, so like Mg plus, and then either an ionic compound, an acid, or water. And we'll usually write the water as HOH so that you could draw a line after the first capital letter, and you know it's the H that is trying to switch with the other partner. So how does single replacement work? Well, in your possibly useful, we will have a chart called the activity series of metals. There's one in your book. There's one on your possibly useful page. It's also out on my website if you need to look at that. So grab a periodic table and make sure you have one that has that possibly useful. Everybody's got access to their book now, so you could always just go into your chapter 9, and there's a copy of it there. It's also on this PowerPoint. There's a copy of it. So when we see one element and an ionic compound, an acid, or water, we know we've got single replacement. We go to the activity series of metals, and you draw a line after the first capital letter in the compound, and the single letter and that first element are going to be battling for who gets to keep the compound. If the one that's by itself is higher on the chart, it will kick out the one that is in the compound. In this case, magnesium is up at the top above hydrogen. So magnesium kicks out hydrogen. We end up with Mg and Cl being together and H2 gas. Why is it H2? It's diatomic. Remember, hydrogen's always H2 when it's by itself. So the Mg has a 2 plus charge. If you see that Mg is in 2A, 2A means 2 plus. Everything in 2A makes 2 plus ions, and that gives MgCl2. So we've got H2 and Cl2. We put a 2 in front of the HCl, and now we're balanced. That's single replacement. If it were the other way, if the hydrogen gas and the MgCl2 were reacted, there would be no reaction. Why is that? Because hydrogen is weaker than magnesium. Okay? Magnesium's higher on the chart. So we would write NR, no reaction. There's no reaction type. Remember, your activity series, the only reaction that uses activity series is single replacement. There's a question on the test about double replacement. Does it use the activity series? And that's definitely a no. The double replacement reactions have different rules for how they react. So, go in and talk about the last type of reaction, which is double replacement. Double replacement reactions have 2 ionic compounds. And the 2 ionic compounds are on the reactant side. It's the only one that has that. So you should be able to go through now and recognize all 5 types of reactions by what they look like. So let's look at one here. Let's do MgOH2. Magnesium has a 2, OH1. They crisscross. And we also mix that with HCl. Okay? 2 ionic compounds. We count acids as ionic compounds here. So even though some of them are kind of on that borderline. So we draw a line after the first capital letter in both, and the first letter or first element swaps places. And then you re-crisscross on the other side and make the new ionic compounds by, remember, I on both sides, crisscross to write the formulas. So here we're going to end up with MgCl2, 2 plus, 1 minus, we crisscross, plus H is now with OH. So we have HOH. At the end you balance it. We've got 2 OHs, so we need 2 OHs. That gives us 2 H's, so we put a 2 in front of the HCl. That gives us 2 Cl's, but we already have 2 Cl's, so we're balanced. At the end, you should have a balanced equation, and all the atoms on the left are equal to the number of atoms on the right. The key here is whenever you make a new compound, whenever you write a new compound, if there's a metal in that first slot, crisscross to write the new formula. Don't carry subnumbers across. See, the OH has a sub 2. We don't have a sub 2 on the OH on the other side. The reason we don't is because H has a 1 and OH has a 1. When we crisscross, we end up with 1 and 1. Don't carry subnumbers across the arrow. You have to re-crisscross them on the other side. So that takes us through all the types of reactions. Work through some of those practice, work on your review, and you get some practice on your lab also. Hopefully this will help you out. Good luck.